Let's go over pedigrees. Pedigrees are basically a family tree that records and traces the occurrence of a certain trait. On these pedigrees, males are going to be squares while females are circles. Squares and circles that are shaded in are affected and have some trait. Carriers in these pedigrees are half shaded in, and they don't have the trait, but they still have one of the alleles for the trait. Males and females that don't have a trait aren't shaded in, they're empty. When there is a line between two individuals, we call that line a marriage line. When there's a line that protrudes down from this line, that shows a line of descent. That usually means they have offspring. In this case, they have a son and a daughter. Side note, if you see a line through a person like this, that means they've passed away. Now, these pedigrees can show a couple of different types of inheritance patterns. Let's take a look at the different types of inheritance you might find on these pedigrees. First is going to be an autosomal recessive trait, where individuals that have a trait and that are shaded in are a, or homozygous recessive. In these types of inheritance patterns, we use letters like big A or little a to represent the different alleles. Now, one way to identify an autosomal recessive trait is that they skip generations. You can see in this pedigree that this person has the trait. That means they're little a. However, neither parent has the trait. That means they have at least one big A. Now, in this case, the parents, the mom and dad here, are going to be heterozygous for this trait. That means they're going to be carriers. So in this pedigree, we would half shade these in. You can see the mom should be half shaded in and the dad should be half shaded in. That's because they don't have the trait, but they have one of the alleles for that trait. Now, the son here is going to be a big A question mark, since it could be big A, or big A, little a. Autosomal dominant traits are kind of the opposite. We still use letters, but these don't typically skip generations. Affected individuals that are shaded in have at least one big A. People that do not have a trait are homozygous recessive. That means they have little a. In this type of inheritance pattern, there are no carriers, since if you get one dominant allele, you automatically have the trait. In this case, this individual that doesn't have the trait is little a. Now that means both the parents are still going to be heterozygous, however, they still have the trait, since heterozygous individuals will still show that trait. And again, down here, the son here will be big A question mark, since it could be big A, or big A, little a. We don't know which one it is, so it's big A question mark. Our next type of inheritance pattern is an X-linked recessive trait. Remember that males are typically XY and females are XX. In these type of inheritance patterns, females need two recessive alleles while males only need one. As you can see above, we put a superscript letter next to each chromosome, either the X or the Y. In this case, it's the X, to signify whether it's dominant or recessive. So affected females have two recessive X chromosome alleles, while the males only have one. Unaffected females have at least one dominant H superscript next to the X chromosome. Unaffected males have one as well, but since they only have one X chromosome, they can only have one. In this case, the X-linked recessive, females can be carriers. In this case, the X big H, X little h is a carrier. Now, I'm not going to go through every one in this pedigree, but you can see the female here that has the trait has X little h, X little h. She got one of those little h's from dad, but that means she had to get the other one from mom. So this mom right here we know is a carrier, since she has one of the genes but not both, and she doesn't exhibit the trait. Now again, we can flip-flop this and we can look at X-linked dominant traits, where if you get one dominant allele on the X chromosome, you automatically have the trait. So both the heterozygous and homozygous dominant form of this trait in females will be affected. In males that are affected, they have one dominant allele. Unaffected females are X little h, and unaffected males are X little h, y. You can tell in this pedigree that this male inherited the trait from the mother. Since he inherited the Y chromosome from dad, the X chromosome had to come from mom, so he inherited that X chromosome with a dominant allele from mom. Now, technically, mom could be X big H, or X big H, X little h, so we don't know which one it is, but we know she has at least one big H. And lastly, we have Y-linked dominant traits, where in this case, if you have a Y-linked trait, you're automatically going to have that since you only have Y chromosome. So this only affects males. So as you can see in the pedigree, this is passed from father to son, and every son of a male that has this will have the trait, since the Y chromosome has to be passed from father to son.